Okay, the last thing in section 2 that we need to go over would be definitions of horizontal and vertical asymptotes. Obviously, any horizontal asymptote is going to be y equals a number, and every vertical asymptote is going to be x equals a number. That's how we write all of our horizontal lines and vertical lines. But we need to look at different limits that exist around those, or we need to look at the definition based on limits. Horizontal asymptotes deal with something called end behavior. Wow, blinking lights. Not to be confused with end behavior like when you're sick and you've got a bucket and you're on the toilet. That's a different kind of end behavior, folks. Never mind. Where on a graph do you find positive infinity for the x's? Where do you find positive infinity for the x's? Way far over to the right. Where do you find negative infinity for the x's? Way far over to the left. So, keep that in mind. We're talking about the extreme x values on the far right and the far left. And what this definition is saying is that your limits are actually going to a number. You're actually getting closer. Now tell me again, is a limit a y value or an x value? A limit is a y value, right? We describe what's going on with the x's. X is getting really, really big in the positive direction or really, really small in the negative direction. But a limit itself is a y value. Look at the picture over here on the left side. Just based on the picture, if you go really far to the right on this graph, what do you think the graph is getting closer and closer and closer and closer to? What do you think that's getting closer and closer and closer to? -2, it looks like. So based upon this picture, the limit as x approaches positive infinity of whatever this graph is, let's call it f of x, looks like it's getting closer and closer to -2. Is the same thing happening on the other side? Does it look like it's getting closer and closer to -2 on the other side? Yep. So what's the horizontal asymptote? Be more specific. How do you... I mean, I understand the number is -2, but that's not the equation of a horizontal asymptote. Or any horizontal line in the universe. How about y equals -2? Yeah, Mr. Staley, you knew what I meant. I understand. I knew that's what you were going to say.
I have a question.
Yep, ask.
How come it's -2, its limit f of x equals -2, and how come it's on the right side? How come it's still -2 and not 2?
Well, take a look at the picture. We're not getting closer and closer and closer to... The limit would be +2. It's not coming up all the way to +2. It's getting closer and closer to that line at y value of -2.
Okay.
So it never crosses that line, let alone gets up to the x-axis and goes above to get to 2.
Yes.
Good question. Now, what happens if you get close to a value? Instead of going to infinity, what happens if you get close to a value and you get one of these infinite discontinuities. Infinite discontinuities. So when you see this definition and it talks about it's a vertical asymptote as you're approaching from the left side, right? Because this is talking about approaching from the left of a particular value, you get positive or negative infinity. Another way to say that is does not exist. Same thing if you're approaching from the right, you get positive or negative infinity. Another way to say that, AP Calculus would acknowledge that as does not exist. Those situations, that's that infinite discontinuity we talked about when we were discussing domain issues. Those are creating the vertical asymptotes. So if you look at this picture, do you see any infinite discontinuities in the graph? Please, oh please, oh please tell me you see them. Can you name any of them? Okay, you got about 30 seconds to talk this over with a neighbor and figure out where you see any infinite discontinuities. On this and I become one here, I have to pick up my pencil and start again, right? Where did I have to pick up my pencil? Which x values, right? Remember the discontinuity is x values.
Oh, negative 2.
That's true. Right? Correct. Where would you have to pick up your pencil? Negative 2, definitely a problem right there, isn't it? If you're drawing this particular branch right about in here, you'd get tired of drawing and you'd pick up your pencil. And then you come up here and you draw this part, right? So that's an infinite discontinuity. You can see that the limit does not exist at negative 2, does it? Because as you come from the left, you're going down forever, right? That'd be that negative infinity, or does not exist. And as you come from the right side, you'd be going to positive infinity, or that does not exist. There's an infinite discontinuity there. So what is the horizontal asymptote, abbreviated HA? Sorry, I should have wrote that vertical asymptote over there. Any ideas? X equals negative 2. But that's not all. There's another one, isn't there? Because coming on the other side, right? As you approach from the left, it goes up and up and up and up and up. Then you have to pick up your pencil and come down here and draw more. So, what's the other one? Yes, sir. Is that the equation of a vertical line? Oh, x equals. Oh, you knew what I meant, Mr. Staley. Unfortunately, the red pen of death does not know what you meant. Please make it clear to the red pen of death. I do not want you losing points for something so simple. Okay? So infinite discontinuities cause your vertical asymptotes. In behavior, as x goes to infinity and to negative infinity, that's where we're looking for our horizontal asymptotes. Okay? Do me a favor. Take 20 seconds or so and factor the denominator for me, please. Factor the denominator. I should say I'm available. I don't get coming in on a flex day. Maybe at home flexing. That's what I'd be doing. Yes, sir. Sure. Here. Fill out this form in triplicate. I don't know if the kids know what that means, but. So what do you got down there? X and X. Any thoughts out there on factoring the denominator? Yes, Mr. Fields. Giving credit to the wrong kid. I apologize. But you are right. X minus 2 and X plus 1. That may come in handy. I wonder what the graph of this thing looks like. X over, y equals X, I will. Got to have the variable X squared minus X minus 2. Did I do that right? Is it minus X minus 2? Yep. All right. Look at the graph. Tell me what's going on way out there. What's the limit as x goes to positive infinity? What's the limit as x goes way out there? What's it getting close to? 0. What about over here? If I go way far this way, the limit as x goes to negative infinity. Also getting closer to 0. So, alright, we just limit as x approaches infinity. And we'll just call it f of x just for abbreviation's sake, because you said that was 0. And you said that as we approach negative infinity, the same thing happened. So what does that mean? What did we find out? We found a horizontal asymptote, didn't we? At what? Limits are what? X values or Y values? Y values. So, what's the horizontal asymptote? Y equals 0. That's true. Okay, go back to the picture. Tell me what you see in terms of infinite discontinuities. You see any infinite discontinuities? Any? Like what? I gotta vote for one.
Negative 1.
Oh, negative 1. Yes, 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 I would agree with negative 1. Definitely a strong positive 1. Anything else? 2? More coloring or more rough? All right, so let's see here. We found those vertical asymptotes at x equals negative 1 and x equals positive 2. Would you look at the factored form that you told me about up here? Look at the factored form denominator. What would cause a problem for that denominator? What would cause a problem for that denominator? 0 would be fine. I can plug a 0 in there, no problem. The world will not end if I plug in a 0. When would it end? If you plug in what? A positive 2 or a negative 1. Oh my goodness! Those are like the infinite discontinuities. Ding, ding, ding. Your vertical asymptotes can be found from the factors of the denominator. Write that one down. Your vertical asymptotes can be found from the factors of the denominator. Oh. So I could have just factored the denominator and boom, I would have seen them right away. That's true. As long as it is factorable. That would be kind of evil if we threw something at you that wasn't factorable. No, we wouldn't do that. We would not be that cruel. That would be evil. That'd be, I mean, cruel and unusual. I think it's something in the Constitution about that. Now, something else that's important with these so-called rational functions would be the largest power of x in the top and the largest power of x in the bottom. I'll just put ditto marks so that I don't have to write it again. Largest power of x in the top and the largest power of x in the bottom. That's an important fraction to you. In fact, I would like you to reduce it. What does x over x squared reduce to? When you reduce it, well, that's a bad looking U. What does x over x squared reduce to? Pretty sure you guys did stuff like this in Algebra 1. Come on. Reduce it. What you got? 1 over x. Thank you very much. It's an important reduction. What happens if you take the limit as x approaches infinity of that reduced fraction 1 over x? Okay? Let me describe it to you, and then I want you to talk it over with your neighbor. State Farm or otherwise. As x gets bigger, so let's see here, like a million. 1 over a million. 1 over a billion, 1 over a trillion, 1 over a Google. Yes, bro. It sounds like people like throwing up, like take the trash and bro. You know what I'm saying? I can't quite figure that one out. Do we know what a Google is? Because there were some people second period who were kind of lost when I said Google. They just thought it was a search engine. And you want 100 zeros?
Isn't Google named after the number?
It's one, yes. One with 100 zeros. Okay, so anyway. You talk to your neighbors and tell me what you think's going on with that. Yes, sir. Well, it actually does, okay? So, but the problem is, on these old-style machines, the old-style machines draw in the asymptotes when they shouldn't. It actually thinks it's supposed to connect the branches. So if I were to, let's see, maybe I'll go -5 to +5 to kind of give you a better feel for it. It's still going to connect the branches when it shouldn't. So mine had this branch over here, and it had that middle part, and then it had that other part over there. So you have the correct picture. It just, also because it's the pixels are kind of, even if you got more, if you even went even closer, like, -3, +3, took a look at the picture, you would get more of the shape or flavor of the graph. Okay, so what happened? 1 over a million, 1 over a billion, 1 over a trillion, 1 over Google. What are you getting close to? Well, those numbers are not big numbers. 1 divided by a million. First of all, it is a positive number, right? It's a small positive decimal, right? Is 1 over a billion getting smaller or bigger? Smaller. Is 1 over a trillion getting smaller or bigger? So we're getting closer and closer and closer to what? 0. How is that useful information? You just found your horizontal asymptote. Now this little trick of taking the largest power of x on the top and the largest power of x on the bottom works great with rational functions. Rational functions. And it's something we will see. Let's take a look at example 11 here. Largest power of x in the top and the bottom. There it is. Reduce it. What does that reduce to? Three x over x squared. What does that reduce to? 3 over x. Now, we want to take the limit of that as x approaches infinity. So 3 over a million, 3 over a billion, 3 over a trillion, 3 over a Google. What's going on? Still getting closer to 0. Hey, what if that number wasn't 3? What if it was 1,000?
Okay.
So in other words, you're telling me that that multiplier on the top is irrelevant because the denominator is growing so fast, it swallows it whole. Yeah, pretty much. All right. How about B? So we want the limit as x approaches infinity of what? Of 3. Okay, let me boil this down for you. Here's the sequence of numbers. I'm going to write them out for you. 3, 3, 3, 3, 3, 3, 3, 3. What do you think we're getting close to? 3. Yeah. Folks, you just found that the limit was the horizontal asymptote of the graph is going to be 3. Right? Here we had y equals 0 for this one. Here we have y equals 3 for this one. Pretty easy. What about this? That's 3x, right?
B equals 3? Like 3 over x equals 0?
Hold on a second. Are you talking about for letter C?
For letter B.
Letter B. So, because you're getting the actual value 3 every single time, that's trying to tell you that we're getting closer and closer and closer to just 3 over 1. So that is the horizontal asymptote, y equals 3. So this one right here, you said 3x cubed over x squared, what does that do? Reduce it. 3x. Okay, folks, we're going to take very, very big numbers and multiply them by 3. What's going to happen? Does the limit exist? Ain't no way, right? You know and I know it's getting close. It's continuing to positive infinity. Likewise, these limits can be done with x going to negative infinity as well. So what's happening here? So the reduced version of 3x to the 4th over x squared is 3x squared. So x is getting bigger and bigger and bigger and bigger and bigger. Not only is it getting bigger, you're squaring it. Then after that, you're tripling that. Eventually, you're going to have to run into a Google, square it, then triple it. What's going on with that? It's out of control. Yes, exactly. The limit does not exist. Right? All right, let's see if we can match some of these pictures up. We'll call them 1, 2, 3, and 4. 1, 2, 3, 4. Do you know which one goes with letter A? Do you know which one goes with letter A? Okay, letter A we said had a horizontal asymptote at y equals 0. A horizontal asymptote at y equals 0. Now don't get it confused with vertical asymptote. In fact, folks, none of these have vertical asymptotes because if you take a look at it, every one of them has an x squared plus 1 for a denominator. And you and I both know that ain't factorable. Not with real numbers anyway. Any of those have y equals 0 as the horizontal asymptote? Yes, Mr. Prasad. What do you got? 1 and 3? Nope. 1 does not have a horizontal asymptote at all. It does not get closer and closer and closer and closer and closer and closer to any horizontal line. 3 does have a horizontal asymptote, but it's not y equals 0. I got to vote for 4. Does it look like on number 4, if you go far to the right, you're getting close to 0, and far to the left, you're getting close to 0? Ding, ding, ding. Now, what did we tell you last year about asymptotes? We told you that they were lines that you got closer and closer and closer to, but never touched or crossed. Well, folks, we kind of lied to you a little bit. We lied to you to protect your innocence. Now, that's a great definition if we're talking about going to positive infinity or going to negative infinity. But it says nothing about what happens in the middle. And as you can see, right here, right through the horizontal asymptote. I know, folks, earth-shattering. We did lie to you a little bit. We just never showed you an example like that one. We showed you nice ones. I know. How about letter B? Which one has a horizontal asymptote at y equals 3? The third one. Yes, there's that y equals 3. You can see that coming right through the graph right in there. Okay. Next two are a little bit unusual. I bet that C goes with number 1. This is my guess. C goes with 1 and D goes with 2. Now, here's the reason I'm suggesting that. Now, doesn't number 2 look like a cubic function? A cubic function is going to grow faster. It's going to grow faster. So when we have here the limit at 3x squared, and, you know, I want to double check this one because it's not as obvious, but that is my thought process. So might as well type it out and see if I'm right. Okay, so we got a 3 there, x to the 4th. Let's go over here and just do it over here. Equals 3x to the 4th divided by x squared plus 1. Whoa. I was wrong, wasn't I? Yeah, I was. The other thought that crossed my mind was these lines kind of looked straight. So that was kind of the other thought that ran through my brain was you had kind of a linear function and a quadratic function. But that little thing in the middle was kind of confusing me. So, yeah, obviously I was wrong there. C goes with that one, D goes with this one. Well, but the parabolic nature of letter D and the graph of number 1 kind of goes with that. What I was I was confused with there was the 3x. But maybe I should have just focused on 3x to the 4th, which would be more of a parabolic shape, and 3x cubed, which would have been more of the cubic shape. That's probably how I should have focused on that one. But since those didn't have limit or horizontal asymptotes, they weren't sticking out like sore thumbs. Okay, now, have you come across ones that we can that you are struggling with that you need me to go over with you? You got to pick something. You've been working on it, and I don't want to see my face. What is going on? Why is it using that video? I'm going to have to shut that off. Why is it using the video? I didn't want to use the video. Alright. End the meeting. I just wanted to do the annotation feature. I don't know. I'll have to figure out my settings on that. Get that shut off. Alright. You got any that we need to do? You've been working on them, and if you haven't been working on them, it's really not a wise decision. I know we've been taking a little bit of notes at a time, but you got any of these odd ones that we need to go over? Number 9. Sure, x squared plus 4. Find the domain. Alright, so what's the picture look like? X squared plus 4. So what is that? I know it's a parabola. What's the plus 4 do to it? Up 4, right? 1, 2, 3, 4. And we got our parabolic shape. They're asking about domain. We talked about how all we had to do is take all the points and push them down on the x-axis. Tell me how much of the x-axis gets covered. That's true. All there is. Picture does give me my domain. For those of you who think you can get away from a basic sketch of the picture, it really isn't something you can avoid. Yes.
So for solving all those,
You would have to. Now. I'm not saying that you can't come up with some basic information out of them. Like on number 11, you should see the vertical asymptotes very obviously because they factored the denominator for me. Correct. So that creates vertical asymptotes, which are your infinite discontinuities. That's going to help you right there. But I really think it's important that you be able to not only see, we got a problem at -3 right here. At -3, we've definitely got a problem. And we've got a problem at x equals 1. So in terms of domain, you should be able to say, well, you're going to have everything from -infinity to -3 union what? Then what? Then you'll have from -3 to +1. Then what? 1 to infinity. You'll have those pieces. The picture is important, though. I do agree with you. You really do need to have the picture. So the idea that you could do everything without a picture is, I would not do that at all. Okay, so if you were thinking, hey, I got to be able to do this all without, no. Man, you guys are ready to go. Why would I? Oh, I will. That's what I'm doing right now. It's just they're so eager to get out of here, They're impatient. That's what they are. So, I would definitely take a look at the picture because the picture gives me a lot more information. But, yes, I need to see the picture in order to be able to find that domain of those 3 sections. Tomorrow we'll answer any more questions that you have from the 1-2, so I would make sure you have gone through this as much as you can. No.